Welcome back to the School of Muscle. Today, we have on Greg Knuckles. Greg is an author at StrongerByScience.com, and he's also involved in a research review called MASS, Monthly Applications of Strength Sports, where he helps digest some of the most recent studies on hypertrophy, strength, coaching, all of those things. Greg really knows the stuff. If you've ever read any of his articles, you know that he's very thorough and really understands the whole science side of this stuff. And not only this, but he's very strong himself and he applies this stuff with himself and people he coaches. And on today's episode, we discuss training frequency, why muscle actually stops growing, whether you need to increase volume over time to keep eliciting adaptation, and things like that. So without further ado, Greg Knuckles. All right, Greg. So the first kind of topic that I'd like to discuss with you here is kind of frequency and how it relates to hypertrophy. And you recently wrote up just banger article on frequency and hypertrophy. And one of the kind of the takeaways, at least for me from the article, was that each additional increase in frequency, each additional time you trained a muscle group per week above one, resulted in, on average, like a 20% increase in hypertrophy. And I just like if you could speak on that. Is that like crazy as it sounds, or kind of what's going on there?
So a couple things. First thing is just like keep in mind the confidence interval on that. So if you do like a slope analysis, that seemed to be like the mean increase within the literature we have. But the confidence interval was like quite wide. So anywhere from like maybe 5% better up to maybe like 40% better or something like that. I don't remember like the exact confidence interval, but it was quite large. So yeah, like it could very well be not much of a difference at all. It could be a difference considerably larger than 20%. It's just hard to say because the research is rather heterogeneous. And one other thing I'd add as well is that I actually need to go back and update that article. So like frequency research is bonkers right now. The first frequency study was from like early 80s, I want to say. And from like 1980 until like mid last year, there were maybe like 5 decent papers that tested like different frequencies, but with volume matched. There were some other not volume matched. So basically like, if it was 1 time per week versus 3 times per week, 3 times higher frequency would also be 3 times higher volume. I find those studies less interesting because like, yeah, of course, more volume is going to mean more hypertrophy. But in terms of like volume match frequency stuff, there wasn't much at all out there until like last year. And then there have been like 10 papers published in just like the last 18 months. And so since that article came out, there have been like another 3 studies published that all had like null results. So when I go back and update all of my analyses, it very well could be that the difference is no longer significant. I still think that the results will overall kind of lean in favor of higher frequency, but I don't know if it'll like clear the bar for statistical significance anymore. But yeah, so and then the one other thing is like the like 20% greater gains. I feel like that's one of those things where you hear that and you're like, oh, that's considerable. Like that sounds like a big difference. But at least like if you've been training for a while, I don't really even know for a lot of people if that'll be a noticeable difference. Because let's say you've been training for like 4 or 5 years at this point, and like a good year of training can net you like 2 pounds of muscle growth. Then that's the difference between like 2 pounds and 2.4 pounds. And like, that's not nothing, but are you really going to be able to tell the difference? Who knows? So yeah, like I do think, and I would also say that the frequency research is, I would say, a lot clearer with regards to strength than hypertrophy. When I go back and add those 3 studies to my analyses, Um, I think it might still be significant for hypertrophy, but I'm not entirely sure. I'm quite confident it will still be for strength. Um, so yeah, we'll just see. And also one other thing I'd add is like I think that both dominant experimental models for looking at the effects of frequency on hypertrophy have major drawbacks that limit their utility in the real world. Um, so like I said, I don't think the ones where volume isn't matched, but like volume scales linearly with frequency, like I don't think those are overly informative because I think they're mostly just testing the effects of volume. Um, but I also don't think that the volume matched research is ideal either. Simply because like when like most people are going to increase frequency so they can increase volume. But like if they double their frequency, they're probably not also going to double their volume. So I think like how frequency kind of manifests itself in the real world is kind of between those two experimental models. Um, and I don't think any studies have used an approach like that. And I think that if someone tried to study it like that, it would be impossible to get published because the reviewers would be like, well, what variables are you standardizing here? Um, so yeah, like it's a tough thing to study. Um, and like the reason I say that, like most people, like a hard leg training session, like maybe you're doing, I don't know, 10, 12 sets of leg exercises. And like if you're just training legs once a week, like that's a lot of volume in a session. And like where do you want to go from there? Like do you want to do like 25 sets of legs in a single session? Like hell no. That's going to be terrible. But if you split that up over like 2 or 3 sessions, that can be very, very doable. So most people do use frequency primarily as a tool to increase volume, and I think that's probably the best application for it. Um, but it's also not like a linear increase in volume. Like people don't, if someone trains legs on Monday because Monday should be International Squat Day, not International Bench Day, because squats are better and cooler, and that's an objective fact. But yeah, so if someone's doing squat day on Monday and they decide to add another squat day during the week, they're not just going to copy and paste Monday's workout to Thursday or whatever. So I think the volume matched frequency research at this point for strength leans very strongly in favor of higher frequencies. For hypertrophy, I think it leans kind of in favor of higher frequencies. But I think in the real world, the benefits you would see from higher frequency will be larger than what you see in the volume match frequency research, typically because higher frequencies do let you like comfortably handle higher volumes.
Right.
And another thing I'll add, and this is like getting super off into the weeds, and I realize I'm rambling at this point,
right.
But you've listened to my podcast, you know how this goes. Uh, so I think that I think this is something that's like somewhat poorly characterized in the literature at this point, but we have some hints pointing us towards it. I think that there's a relatively moderate maximum per session volume that people can benefit from. And so like for example, if you compare several of the like volume, like different weekly volume studies. So like the Rodelli study, the most recent Schoenfeld study, the Ostrowski study. Like all three of those studies had training frequencies of like 2-3 times per week. I think it was 3 times per week for Schoenfeld and Rodelli and twice for Ostrowski. I can't remember though, but like used a weekly frequency per muscle group of greater than 1 and tested different weekly training volumes for hypertrophy. And they all generally tended to show more muscle growth with higher volumes. It wasn't for all of them. It wasn't necessarily like at each level they were different, like significantly different from each other. But that is kind of the trend you see across all three of those studies. And then more recently, like just last week or maybe like 2 weeks ago, a study was published finding significantly greater hypertrophy with, I believe, 10 sets per week than 20 sets per week. which like runs counter to those other findings. But the difference was the training frequency per muscle group in this more recent study was just once per muscle group per week. So I think that kind of shows us that like on a per session level, volume can absolutely get too high and can probably get too high at relatively moderate levels of volume. Like I don't think there's ever any reason to like go in and do 20, 30 sets for a single muscle group. And so I think that, and this is going to vary based on the individual and their training background and all of that. But I think like on a per session basis, there's a fairly moderate amount of volume that you're going to be able to benefit maximally from. And then from that point, if you want to increase weekly volume, it would actually be a negative thing to keep increasing per session volume. And that would necessitate increases in frequency from there. And I think that one of the reasons you don't tend to see big differences in the volume match frequency research in terms of hypertrophy is because most of those studies do use like what I personally would consider to be like low to moderate training volume. So like, the 1 or 2 times per week frequency group, like that one session, it's not like they're doing 30 sets for a body part. They might be doing like 10. And then the higher frequency groups are just doing like maybe 2 or 3 sets per body part per session. So yeah, I think that that's one area where there's kind of a disconnect between the research and how it's applied in real life. So yeah, like I think that the biggest issue with lower frequency approaches is just the total like productive weekly volume you can do is going to be reasonably low. Because if you keep increasing volume for like, a single session per week for a muscle group, I think you reach the point relatively quickly, like maybe 10, 15 sets for a single muscle group in a workout, past which point like gains are going to plateau and potentially even regress. So yeah, like I think that all of the training variables that one would talk about, you need to talk about how they relate to the other training variables in play. And I think that there's like a very synergistic relationship between volume and frequency, such that like, if you're training, like let's say you're doing 5 sets of squats per week and that's all of your leg training, I don't think it fucking matters what your frequency is. Like that volume is so low, like you're going to benefit from doing all of that in one session. And who knows, if you're just doing 1 set of squats in a session and that's like your entire leg workout, that volume may be too low for it to really do much. If you're kind of pushing volume a little bit harder, then I think that as volumes increase, the benefits of higher frequencies increase as well.
Yeah, I think that makes a lot of sense. And on the flip side, do you think that there's a minimum amount of volume in a single session that is worth doing? Like, do you think that just like, say someone wants to do a high frequency approach for like their delts or biceps, do you think that just doing like 1 session or 1 set per session is like not enough to really stimulate like hypertrophy? Or do you think that you can still get some out of just a single set?
That's a good question. Most of the research looking into that at this point uses untrained subjects. And with untrained subjects, like, yeah, one set is plenty. And like when you meta-analyze them, higher volumes seem to be better, but a lot of like the individual studies don't actually find significant difference between like 1 set for a muscle versus like 3 or something like that. My definite hunch is that like the minimum required volume for it to really do anything productive is probably a bit higher for more well-trained people. But I still don't think it's incredibly high. Like I think like if you do like maybe like 3 or 4 fairly challenging sets for a muscle group within a session, like I definitely think that's probably going to be enough for like to do something for most people. And who knows? It may be 1 set. Like my hunch could be completely off because there's not that much research looking at that. But yeah, I'm really not sure. And also, I think like the details of that set probably matter. So if it's like a moderate number of reps like taken to failure, like like a straight up 10 rep max on something, like that's hard. And especially like if you're quite strong, that's really hard. Like if I do a legitimate 10 rep max squat, like I'm done for like 25 minutes after that. But and like, it kills me now that it's like high fives, but like it didn't kill me to the same degree when it was like 315 or something. Um, so yeah, like versus if it's just like a heavy double or if it's like a set of 6 with 3 reps left in the tank. Like I think all of like it, it's hard to say like one set will be enough if you don't have more details about what that set is and what it entails. Or even like I know of a lot of people who've like put on a lot of size just from doing I don't know what the cool kids call it these days. Like we just called it 20 rep squats back in the day. Then folks called it like death squats or whatever. But like a 20 rep max squat, like just or really a 20 rep max, pretty much anything like heavy compound lift. That's hard. And like I know if specifically with squats, like I've seen quite a few like very experienced lifters, do a 20 rep squat once or twice a week and put like a noticeable amount of size on their legs. Whereas like I definitely don't think that would happen if it was like a heavy triple once a week. um, so yeah, like it's hard to just state in generalities about like what a set will do without knowing more about what that set is.
Right. That makes a lot of sense. And something you kind of touched on there was that kind of the stronger you're getting, the pushing a single set might take you out for a longer period of time. And something that's I believe like Brian Miner brought this up was that volume might not actually have to go up over time, since you might be stressing your muscle a little bit more on a per set basis if you're a little bit stronger. Do you think that sounds reasonable, or what do you think about that?
Oh man. So I think a lot of it has to do with how effectively you can use the muscle you have for a particular exercise. And also I think like ultimately it's a question of like what can you do and then also what can you recover from. Um and so like one thing we know is like muscles adapt and strengthen a lot faster than tendons do. So like, the gains in muscle strength that you might make in 2 years, like it might take like 5 or 10 years for your tendons to like fully catch up and like the ratio of like muscle strength to tendon strength to be like what it was pre-training. Um, and so I think that like if you're calculating volume as like number of sets per week versus like volume load, I think that for a lot of people, like once you get really, really strong, I think the total amount of volume you can just simply recover from starts trending down. Um, and so I know you also want to talk about like why hypertrophy and like strength gains eventually stop. Like it very well could be that the amount of volume you need to keep adapting and progressing keeps trending up, while the total amount you can recover from just simply due to the tissue stress you're placing on yourself trends down. And it could just be like when those two lines cross each other, you're just kind of done. So like that's a distinct possibility. Um, but I think that a lot of it has to kind of do with like neuromuscular efficiency type stuff. Um, so like, first time you get under the bar to squat, like you're terrible at squats. You don't know the movement. You're gonna move like a baby giraffe, like all like wibbly wobbly. And like, once you get the form down a little bit, like you can go hard and like you can go to the point that you can't get another rep. Um, but like, have you reached that point because you've actually like fully exhausted the muscles that you're using, or have you like? I'm skeptical that you are capable of inducing as much local muscular fatigue at that stage as you are if you're considerably more well trained. Because like eventually, like you're just not going to miss a squat because of technical breakdown. Like you may for like a 1 rep max, but if it's like, a 10 rep max or something, like you're never going to get so badly misgrooved on a 10 rep max squat that like you just fail way before you should have if you have 10 years of squatting experience. So I think you're capable of inducing more both local and systemic stress on a per set basis as you get more well trained. Not just because the weights are heavier, but just because like you can more effectively like use and fatigue your muscles during those sets and like get closer to like true theoretical muscular failure versus like failing for some other reason. So yeah, I think that as you get more well trained and just like neuromuscular efficiency increases, you're going to reach a point where like when you fail on a compound lift, it's because you're actually closer to true muscular failure versus like, just fatiguing and missing a lift due to some other like technical reason. So I think that even independent of weight on the bar, you can just induce more total stress throughout the set as you get more well trained. And just kind of what I've seen as far as like volume requirements go for people, like I think that when you start training, you can't recover from jack shit. Like, you do like 2 reasonably hard sets and you're crippled for like 5 days. But I think like the amount you can recover from and the amount you need to keep progressing does kind of keep trending up for maybe like 2 or 3 years or so. But then, yeah, after that, I agree with Brian. I think that if volume requirements do keep going up past that point, I think they keep going up very, very gradually. Or they might just completely plateau with like the amount of stress you're like. So it with anything we track, whether it be volume, intensity, whether that be relative or absolute intensity, like anything like that, ultimately we're tracking those things because they're proxies for the stress we're imposing on the tissues to hopefully cause adaptation. But like they are proxies, like they are not the stress itself, if that makes sense. um, so it could be that like the total amount of stress you need to keep progressing does keep going up, but at the same time, the amount of stress you are capable of inducing per unit of volume also keeps going up, such that like the amount of volume you need to induce adequate stress doesn't really change all that much. At least if you're looking at volume on like a per set level. Like as you keep getting stronger, like volume load is going to keep trending up, obviously. But yeah, like I think like you do keep needing more and more stress, but like the stress you can induce per unit of volume is also going up as well. So if volume requirements do keep trending up after 2-3 years of training, I think that the rate at which it increases would be very, very gradual.
Yeah, that makes a lot of sense. And so if someone's if the thing that's kind of bottlenecking someone is actually like joint stress and things like that, and how well you can recover from that sort of things, do you think that like a period of kind of lower volumes to where you really reduce, like kind of a resensitization phase is kind of what's been thrown out there, a period of these lower volumes to kind of let joints and connective tissues and those things heal up? Do you think that that could potentially be a way kind of around that to kind of benefit hypertrophy? I guess the flip side would be that if you do that like a month-long period of lower volumes, you might actually reduce your like recovery capabilities of volume and stuff as well. So what do you think about
and
that?
also during that period, you're not causing further connective tissue adaptations.
Right. So you think that might not be a good idea for healing up connective tissue and stuff like that, so you can then overload yourself a bit more?
I really don't know. Do we want to shift to this area of the conversation now?
Sure,
let's do it. So yeah, why do people stop growing in the first place? I think that's a fascinating question because like no one ever looks at it. Because like just think about what you would need to actually do to study that experimentally. You would need to like conclusively establish that people that like the group of people you're studying have just completely stopped growing. So, that would probably require several months of lead in where like you're training these guys and like measuring muscle growth just to make sure they don't keep growing. And most of them who think they've like fully plateaued can probably still keep growing. So like that's another thing you see in the research all the time. Like there will be a study that says like, oh, we have trained subjects, average training experience of like 5 years. We trained them for 12 weeks and their squat went up 20%. Like that shit doesn't happen if they were actually training hard for 5 years. So I think a lot of people they've plateaued and they think like, oh, I can't keep growing anymore. Woe is me. But it's like, no, like you just haven't been training hard for the last 3 years. Um, and so like one, I think it would be a bitch to study because I think a lot of people who would volunteer to be in the study wouldn't actually be at that like theoretical end point of muscle growth. So like, you would invest months in these people just to eventually weed them out. And then also like just recruiting would be terrible in the first place because how many high level lifters who've been at it for like 5-10 years and like are fully plateaued are like, yes, Mr. Scientist guy, I'm going to turn my training over to you for the next several months just so you can like poke and prod and experiment around and see if it does anything. Like, so there's not going to be that many volunteers. You'll wind up wasting a bunch of time with each one, mostly weeding them out. And then like there are a lot of potential ways that maybe you could kick growth off again. Like maybe people just maybe it's novelty. So like that's something that's proposed a lot. Like a lot of people over a period of years train in a relatively similar style, and so maybe if you take a power lifter whose growth has plateaued for the last 3 years and you put them on a really really high rep based training program, maybe they'll start growing again. Like maybe it's just something having to do with novelty, and like vice versa for a bodybuilder. Maybe they've been doing like high rep stuff with like short rest, and if they gave powerlifting a shot, like higher intensity work, longer rest intervals, like maybe just that novelty would do something. Maybe it is training breaks. Maybe it's just volume. Like maybe if you bump these guys' volume up 50%, they'll start growing again as long as they don't die of overtraining first. Like, so like there's a lot of potential things you could try. And just like going down that list, like maybe there's a half dozen things you'd want to try, and you can only try one for each study. And so just pulling off that study in the first place, like just one of them would probably take 2 years with recruitment and screening. And then you try it and, oh, it doesn't work. And so like, now let's redo that entire process to try the next option on our list. And also keep in mind, like none of this is going to be funded because like the NIH really cares about like, oh, how can we keep more muscles on seniors so they can maintain quality of life and don't develop sarcopenia? Like they don't care about like, oh, we have some bodybuilders whose biceps are plateaued and they really want to add that extra half inch. Like that's not research that gets funded. So you're going to be investing half a career in a question that ultimately like maybe 1,000 people in the world care about. And it would just be terrible. So all of that is to say, like, there's really no research looking at why do people stop growing eventually. Even though I think most of us would assent that it does seem to. Like even with drugs, people stop growing. Like I don't think Big Ramy 3 years from now is going to be another 50 pounds bigger. Like I just don't think that's going to happen. But like especially drug free, people do seem to stop growing at some point. And so the question is like, why is that? So like muscle hypertrophy at the most basic level is just the accretion of myofibrillar proteins or proteins in your muscles. And so the first thing to look at is like, oh, maybe as training experience increases, muscle protein synthesis decreases, muscle protein breakdown increases. And, you just reach the point that those two things are kind of imbalanced and can't keep growing past that point. And the thing is, there's not that many muscle protein synthesis studies in trained populations. And the trained populations they've used aren't like, elite strength or physique athlete populations. But like the research is out there shows that like Yeah, if you look at total area under the curve for muscle protein synthesis after a workout in trained versus control people, total area under the curve is a little bit lower, but we're talking like it's reduced by like a third or like maybe 50%, which if you extrapolate that out would imply that like, oh, maybe growth rates slow down 50% or something. Like that's not what you see. Like I'm not growing at 50% the rate I was in my first 3 months of training. Like, no, like that's not what it is. And it doesn't seem like muscle protein breakdown increases to any meaningful degree as well as training experience increases. So that's not it. Next potential idea is like maybe connective tissue is a limiter. Um, and so I think that's plausible. Just simply the amount of stress you need to grow exceeds the amount of stress your connective tissue can recover from. So, if you kept training enough to make your muscles progress, you just find yourself like crippled and injured with, constant injuries. Um, and I think that on its face seems kind of plausible, but like you also see people where they stop growing and like especially like particular muscle groups. Like maybe someone's never had a hamstring strain in their life and like they want to keep getting their hamstrings bigger and like they keep upping the volume, but like their hamstrings just stop growing. And like that happens a lot, especially like calves. So a lot of people complain about their small calves. And like, a lot of people don't have like proximal calf tendonitis, and like most lifters don't rupture their Achilles. So like, that doesn't seem to be limited by connective tissue. So like, seems like a good idea, but if you think about it a little more, that seems quite implausible. So something where there's a lot of anecdotal support for it, but there's not that much research looking into it, is it seems that frame size has a lot to do with how much muscle you can carry. Um, so my friend Francis Hallway, who's an anthropometrist, he has like a big database of basically like frame size data for a lot of athletes, and from that he can calculate muscle to bone ratio. And this isn't like bone mass that you could get from a DEXA because that's mineral mass. And so he's like trying to calculate bone wet weight, which is considerably heavier than just like the total mass of the minerals in your bone. But so looking at muscle to bone ratio, he finds that drug-free athletes tend to not exceed a muscle to bone ratio of about 5-1 or potentially 5.5-1. And that seems to be like a fairly clear ceiling in his database that he maintains. And he's published some of that data, but not all of it. So it's something where it's hard to say it's established in the literature because a lot of that data isn't published. But just from talking to him and like looking into the research that is out there on that concept, it does seem to support the idea that frame size might be a limiter for how much muscle you can build drug-free. And I think that also makes sense when you look around. Like people with big frames also seem to be able to carry more muscle than people with smaller frames on average. So then, who knows? Maybe it has something to do with bone metabolism. So something that if you ever just want like a really boring weekend, just like pull up PubMed and just type in like muscle bone crosstalk. So like a lot of people don't realize this. Like your muscles and bones aren't really like independent things, and even like your tendons. So people think about those three things as like completely independent structures, but they're not. They're all woven together. So like the connective tissue within your muscles, the endomysium that just like surrounds each muscle fiber, and then the perimysium that surrounds each fascicle, and the epimysium, like all of those things are woven together. They're continuous with the tendon, and they're also continuous with the collagenous matrix of the bone itself. So like, if you've ever tried to debone a raw chicken or like debone like a raw steak or something, like you see that the muscles are like stuck to the bone. So it's not just like the tendon that's attached to the bone. Like the muscles are stuck to it. Like the collagenous structures of the muscle and bone are like interwoven. So like they have a really close relationship. And it does seem like there's a fair amount of crosstalk back and forth between muscle and bone, like molecular and hormonal crosstalk. And so, if we see that the amount of muscle people can carry drug free seems to be influenced by frame size, which is mostly just bone size, it could be that there's something the bones are doing that are, like sending signals to limit muscle growth such that muscles can't contract with enough force to damage the bones that they're attached to. Like that seems kind of out there, but it's also plausible. uh, and really just like those are my ideas. I don't know what else it could be. It seems to be something, but at this point we just don't know because there's not research looking into it.
Yeah, and that was just super fascinating to hear you go over that crosstalk between bone and muscle. I've never ever heard that discussed anywhere before. So that's really interesting. And isn't there also like crosstalk between and muscles also, as well?
Do what?
I was just going to ask, isn't there also like crosstalk between muscles to where if you like train your right bicep, you might see some hypertrophy of your left, or is that something that I'm just...
No, you would see strength increase in your left, but not hypertrophy.
Okay, strength increase.
Yeah, and that's because like improving motor skill on one half of your body also affects the other half.
That makes sense. That makes a lot more sense than increasing hypertrophy.
Yeah. And then like another thing you see is like with disease states, like osteopenia and sarcopenia also go like very much hand in hand. You tend to not see like, and it could be that there's a third factor in play there. So it could just be that like inactive people wind up with weaker muscles and weaker bones. Or it could be crosstalk between the two, or it could be all of those things acting in concert. But people with healthy muscles also tend to have healthy bones and vice versa. And like I said, that could just be entirely due to exercise. I think that muscle and bone are a lot more interrelated than a lot of people realize, both structurally and functionally. And that's also an area where the last time I really looked deeply into this research was maybe like 3 years ago. So there could be a lot more stuff out now. But at least at that point, a lot of people were saying like, oh, look, there's a lot of crosstalk between muscles and bones. Isn't that super interesting? But they were like super far away from actually having all of the details hashed out. So like for me personally, that's my current leading candidate for what might be eventually bottlenecking hypertrophy. But I just have a hard time squaring that with like muscle protein synthesis stuff because like, are the bones doing something directly to shut down muscle protein synthesis? And like, if so, why haven't we seen that in the research up to this point? I don't know. Makes my head hurt a little bit. So one more thing that could potentially bottleneck growth would be myonuclear accretion, also possibly interacting with capillarization and oxygen delivery. So muscle fibers are really, really neat in that they're one of, I believe, only 2 multinucleated cells in your body. So each muscle fiber is just one cell. Most of your cells only have one nucleus. Some of your larger immune cells have like 2 or 3 nuclei, but muscle can have a ton. And basically, it seems like each nucleus kind of oversees a given area of the innards of the muscle fiber, the sarcoplasm. And that for a muscle fiber to keep growing, once it reaches what's called its myonuclear domain limit, which is the point where each nucleus is overseeing as much of the sarcoplasm as it can. So for a muscle fiber to keep growing past that point, it seems to require further myonuclear accretion, adding more myonuclei from surrounding satellite cells in order for it to be able to keep growing. And so one of the things you see in new lifters is that they accrue myonuclei faster than well-trained lifters do. And another thing you see is that people who are high responders to training, people who would typically be termed like genetically blessed with good hypertrophy genes, they accrue myonuclei early in training much faster than people who are less gifted and don't gain muscle as fast. So it seems like that's a really important factor, but we don't have that many studies looking at myonuclear accretion in well-trained lifters. So it could just be that past a certain point, people just stop adding myonuclei for some reason, and that stops them from being able to keep growing. And like I mentioned, that may be related to oxygen delivery. Um, so there was a study in older adults a couple years ago looking at the relationship between capillary density in the muscles, so blood vessel density in the muscles, and myonuclear accretion and hypertrophy. And it found that untrained elderly people with greater muscle capillarization accrued myonuclei better and grew faster than older people with lower capillary density. And actually, we saw something similar in a paper on powerlifters that just came out this past month. So I was looking at blood flow restriction training in fairly high level Norwegian powerlifters. They had one group just doing kind of like traditional heavier front squat training, and one group doing low load front squat training with blood flow restriction. So like, 30% of one rep max to failure. Sounded like really nasty stuff. And they found that the group doing blood flow restriction training, the size of their type 1 muscle fibers significantly increased by like 12% or so in just like 6.5 weeks, which for trained lifters, like that's huge. And then also like whole muscle cross-sectional area increased, I think like 8% in just 6 weeks, which again is like huge increase for already trained lifters. But it did seem to be isolated to type 1 muscle fibers. And what they also saw is that capillaries per fiber for the type 1 fibers increased in the blood flow restriction group, and number of myonuclei per fiber increased in the blood flow restriction group for the type 1 fibers. For the type 2 fibers, capillary per fiber didn't change. Type 2 fibers didn't grow, and myonuclei per fiber didn't increase. So it also seems like in trained lifters, what they found in those elderly subjects in a previous study held true, that the fibers where capillary density increased, myonuclear accretion occurred, and growth happened as well. So, man, where to go with that? So who knows why that would be? So it could just be that it's one of those things where all of the tissues of your body, their prime directive is to stay alive. Like that's what they're trying to do. And obviously, being able to adequately create energy for itself is like one of the main things that it has to do to keep living. And most of your cells primarily function via aerobic metabolism, and that includes muscle fibers. They only go anaerobic for very short periods of time during exercise. For the most part, they operate aerobically. So it could just be that if your muscles in some way are sensing that they've gotten so big. So let's say you have 3 capillaries supplying oxygen to a single muscle fiber. As the cross-sectional area of that muscle fiber increases, the distance from like a given point, like in the middle of the muscle fiber, to the capillaries from which it would be getting oxygen increases. And like the total amount of oxygen available for that entire muscle fiber on like a per unit cross-sectional area basis decreases. So maybe the muscles have a way to sense that and like tell myonuclei like, hey, don't come here. We don't need to keep growing. We're having a hard enough time getting enough oxygen as is. But then once capillarization increases, then the muscle fiber is like, oh, okay, we can keep adding more myonuclei, keep growing. And so who knows? That's a possibility. If that were the case, then kind of like quote unquote like metabolic type strength training might be a good way to go about trying to get past a growth plateau. And man, so I think it would also be really interesting to see if like drug therapies that increased neovascularization, like adding more blood vessels, and obviously like this research would need to be done in mice, since I think ethics boards wouldn't be crazy about it in humans. But like one way to test that would just be like develop drugs that induce neovascularization. I think there are some out there already, but this isn't my area at all. And give them to mice during resistance training and see if that increases hypertrophy. And now that I think about it, there was a study in mice using Viagra as sildenafil as a ergogenic aid during resistance training that found that increased hypertrophy. And sildenafil does its thing by increasing blood flow. So yeah, who knows? Maybe you're at a plateau. Just go to your doctor and say you can't get your dick up. Get a Viagra prescription and see if that does the job for you. But yeah, so and the other potential trigger for myonuclear accretion is muscle damage and the like associated inflammation that goes along with it. So I think that's where the idea of like taking time off to like resensitize your muscles and get more growth comes from. So I think that's a really cool idea. And I wrote an article about it a while ago that I think largely got misinterpreted. Because I was more putting forth a hypothesis where it was like, oh, seems like muscle damage is related to myonuclear accretion. You keep training, your muscles get progressively less damaged. Maybe take some time off, open yourself up to more muscle damage. Maybe that'll help you accrue more myonuclei and keep growing. So it's more like a hypothesis, like, hey, this is a potential idea that might work. And a lot of people interpret it as, oh, Greg's telling me to not train for the next month, so I'll get huge. And I'm like, no, that's not how I meant it at all. But yeah, so that's another possibility that there's potentially like theoretical mechanistic support for, but at this point, I don't know if I'm almost positive there's no like strong evidence supporting it. So yeah, those are kind of my ideas, and I think it's going to be years before we have any sort of like conclusive notion of what's actually going on.
Yeah, I think those all those ideas make a lot of sense, and I think it's important to remember like that these are just ideas. Like we're not saying for sure that blood flow restriction training is going to increase your muscular potential or anything like that, but that's really cool there. And Greg, I think this is about all the time we have today. Where can people go to find more about you?
So I'll start with the shilling because I got to put food on the table. If you're into research and into strength or physique sports, you should check out the research review I put out every month with Eric Helms and Mike Zordos. It's called MASS, stands for Monthly Applications in Strength Sport, where we break down 7 of the basically like most important papers for strength and physique athletes. Thousands of papers get published every month. Most of them are going to be completely irrelevant for strength and physique athletes. And then, past that point, like there are only a handful of papers that might actually affect the way you train or the way that you coach your athletes. So we pull those out. We do the heavy lifting, like reading the stats and the nerdy shit, and try to break it down at a level where you'll be able to read and understand it, but without stripping away the context and nuance. So you can find that at strongerbyscience.com/mass. If you want to just read my free articles, they're on strongerbyscience.com. Follow me on social media, most active on Facebook, on my personal account, not my business account, which I don't think I've posted on in probably like 4 months. Oh God. And then I'm trying to do the whole Instagram thing. Still mostly just food pics and pictures of my dog, but occasionally fitness related stuff as well.
The occasional study comes up on there.
Yeah, sometimes.
Well, Greg, thank you so much for coming on.
Thanks for having me.
Thank you so much for tuning in to today's episode. If you want to do me a huge favor and took value from this episode, make sure to screenshot this bad boy and post it up on your Instagram story. That really does mean a lot to me. But that's all we got for this one, and I'll see you in the next episode of The School of Muscle.